Okay, then let's get started. Welcome everyone. Welcome to the monthly technical steering committee from the EVerest project. Before we dive into, we have to quickly show the antitrust policy. So here could be different competing parties in the room, and just make sure we are not violating anything in antitrust laws. Yeah, so let's directly dive into it. We have like the typical agenda. Quick recap, what's EVerest? What are we doing here? By the way, if you watch a recording, there will be jump marks on YouTube, so you can jump directly to the next chapter if you want. We are part of the Linux Foundation Energy, which is a big project dealing with deep decarbonization of the energy sector with software. So basically the software layer of the power grid of the future. And we're basically the gateway or connectivity to the cars, and in both directions. So grid storage basically within cars, and flexible demand, and whatever you can actually imagine there. Why is EVerest so important? So we are bridging the gap between a lot of different industries, which are all trying to make charging happen, from automotive to AMs to charging station manufacturers, utilities who want to sell energy, payment providers, and yeah, charging station operators. It's literally thousands and thousands of companies in this industry, and we ended up with a really complex and fragmented way of doing things. There are standards, but everyone implements them slightly different, so it's really inconsistent, and this ends up in way too much cost for the entire ecosystem and a really bad user experience because things don't work together as they should. And what actually are we trying to build here is some software layer for the brain of charging stations, collecting all kinds of things around. So tell that a bit more technical, it's from home and solar batteries. We have different APIs there. We have for electric cars, electric grid, different APIs. For grid forecast, things we want to implement, we integrate. We have user interfaces integrated. Cloud payment and cloud management tools will get integrated. With connectivity to the cars, for sure, also to neighboring chargers, so you can balance between different chargers the energy, and also other local consumption. So basically, EVerest is a local energy management systems on wheels, or with connectivity to wheels. Sure, you can say like, oh, let's make a new standard, but actually that would be a stupid idea to solve this mess with more standards, because you then only would end up with more standards, not with a solution. And last but not least, also this is kind of a recap. There is already one hardware available which runs with EVerest, and there's way more to come. The hardware which is available will also be soon hitting the products and market from our friends of chargebyte, also presenting today, Texas Instruments and Phytech, and Mahle, and Foodtech. But we will announce that as soon as there's something more tangible. So what's new? And let me hand over to Kai. You have been there.
Yeah, we've been talking about this at the last TSC, but just as a little reminder, the talk that Pete and I gave at the Embedded Linux conference about EVerest is now finally available on YouTube under the link we have on this slide. And yeah, if that's interesting for you, then please have a look. It's about a 45-minute deep dive into what EVerest is actually about, and with some Q&A at the end.
Yeah. And just a sneak preview for the last slide of the presentation today, we are planning to do a technical architecture deep dive, totally new concept of how we're explaining EVerest and really showcasing different charging solutions in 3 weeks from now. So let's have a look there as well. So next, we have some new team member to welcome. This is Manuel Ziegler, also working for Pionix and taking care of community and development support.
Yes, I am diving just into that topics, documentation, support, and yeah, community building in general. Just a small overview what I'm trying to do in the ongoing weeks and months from now on. What we currently have, I just wrote that here, the tool base that probably some of you have heard already from the last times. Currently ongoing, setting up all the tools we need for doing great documentation. What we also have is one current status of a big documentation at EVerest GitHub.io. And we have multiple sources of tech info pretty everywhere. So I can show you that on the next slide. But these are now my topics for making the documentation better and building up the community around all that. What you see here are the sources of documentation. Currently, we have some pictograms on a website. We have Google Drive documentation. We have brain dumps in the developers' minds. And this big thing here on GitHub, different repositories, documentation and subdirectories, and so on. So what we really need to do is have one glance and one picture of that, one place where we step into the documentation and where potential contributors also can find their way through. Marco, if you can go to the next slide, we will see there what's the plan in short. Nothing big here. What you can expect is we have one entrance point on a website. We have some detail levels, different detail levels. And that's probably the most important thing I would like to do, having one top level overview and going into step by step into detail, not only for the whole documentation, but also for each topic. So each topic will consist of one overview, going onto a medium level, having some kind of pictograms where a developer can have on one glance the information he needs, and then going deeper down there in the detail level. Yeah, if you like, into the code level, if that's suitable for one topic. And yeah, we will have hopefully a great structure there, and not multiple places where everything is stored like currently.
So next topic is again for Kai.
Yeah, just a few short words about the state of our OCPP implementation. Currently, some final work is going into the smart charging profile of our OCPP 1.6 implementation, which basically means that it's getting integrated into the energy management of EVerest, which will then lead to it being probably fully featured, and we can tick that part of the OCPP 1.6 standard off, and then finally have all the pieces in place. This also touched on some things concerning the reporting of meter values. Some meters are some power meters are actually able to give you signed meter values in a format that is then usable for the German Eichrecht compliance if you want to build a charger with that. So we've also extended support for that, and should be on a good foundation there to actually build charging stations that support this in the future. Yeah, that's it.
Then a quick preview on DC charging. Working. Will be merged back to the main line in 2 to 3 weeks from now. It's already public, but just not on the main branches. It will replace the RISE V2G stack by Joseph Community Edition implementation. This comes with the downside that we then have a Java and Python dependency, so not only Java as before, which is both bad, but we're working on getting rid of both with some more ongoing work. And I think this is the right moment to hand over to our friends from chargebyte.
Yes, thank you. I'm Moritz from chargebyte in Germany, and we have joined the EVerest project, and we're going to donate or contribute a few components and our work here. So if you go to the next slide, the first we want to talk about is the what you just mentioned, Marco, the DIN and ISO stack. Currently, we have such a stack in our charge control product line. So we are doing communication products for electrical charging, both hardware and software. And we have this charging stack. It's currently a closed solution. We will contribute this component, that is the communication flow, the charge flow, to EVerest. And the integration should start in this quarter. The existing component already has similar interfaces to what EVerest has, like in terms of MQTT signaling of values and the components it interacts with, but several adaptations need to be done in order to fit into the complete EVerest architecture. And also, what of course is also expected is the ISO-20 integration that will come later, and we'll talk about that in the next donation. I'm keeping this pretty short because I'm not involved in this project currently. Hauke is the product owner for that. He's also online, but you'll see more of this come, I guess, in the coming presentations. Just to give you an idea what this means, what this whole stack does, on the next slide, there's an extract of what the standard defines for the flow control. This is just, as you can see, it's cut off at the bottom. It's just half of the DC path of the message of the message flow, and what you don't see is message flows for plug and charge, for AC, for renegotiation, for a lot of other stuff which are all defined in the standard, which have to be covered by this component. Also, the communication setup and teardown. There's requirements which are attached to the lines there with markers with V2G2. For example, regarding the timing, regarding content, regarding dependencies, for example, the CP state and the pulse width modulation, and so on and so forth. That's what this component needs to do. A lot of dependencies and a lot of, I would say, experience which we bring along from 8 years of doing exactly these communication stacks. It's it doesn't always need to be reinvented, so I hope we can just drop that component in.
And I think also what is really interesting that this stack is massively in use there for years already out there. So it's not some bleeding edge software.
Exactly. It's well proven. It's not the first one. Most of those who've contributed have written. We've been in different companies and we have different other components, so we have some experience in rewriting this stuff as well. But this is well tested across many of the so-called testables or the Charin events for many years already, and it's just working. In terms of DIN and ISO-2, there's some stuff which isn't so well tested yet, plug and charge and so on. We'll come to that. And the last bullet here, or the second to last, message encoding and decoding is also part of this component, which is done by a library, which we'll talk about in the next contribution. So please go on. That is a code generator for the vehicle to grid transport protocol and the XE it uses to transport that. I'll go a little bit into more detail why this is needed, what the motivation is for writing this code generator, and a little bit of the difficulties and the status where we are right now. So, as you all know, a vehicle and charger are usually connected via a cable, unless you're doing wireless charging. This cable has control pilot for the communication control. Let's skip the wireless part of this, but it uses the same protocol as well. The carrier is a power line communication, home plug GreenPhi, which we're not covering here, which is done by the Slack component, for example, setting up that link. On top of that is a TCP IP version 6 link, and using this link, standard socket connection, there is a message-based communication. The protocol we are using here is V2GTP. Next slide, please. So what does this do? It's a message protocol. It exchanges the charging relevant parameters. So in case of AC charging, you can do it quite simply. It's just like switching on a plug in the most simplest case. In the more complicated cases, you do authentication. You exchange various parameters like limits, and especially in the DC case, the vehicle needs to control the charger. So the vehicle battery management system needs to tell the charger how much voltage and current it needs. It will tell it how much energy it wants to request during a charging session. The charger will apply schedules, and the vehicle may choose from these schedules or from tariffs, for example. And additionally to that, we have the plug and charge, which is an authentication scheme based on certificates and signatures, and a lot more stuff, which is exchanged, a lot of relevant stuff. In a charging session. I showed you the message flow. Each of these messages have different contents. These messages are defined as an XML representation via XML schemas. So very strict definition of what a message contains, in which order, and what the types are in there of that data, in order to have some strict restrictions on that, including limits on value ranges, for example. So you can limit an integer to a range of 1 to 20 if you want, and that is ensured by the schema. That is the basics of this protocol. It's defined in the often mentioned ISO 15112, which is state of the art, meaning that is what is basically deployed everywhere and in use. Originally, DIN 7121, which is legacy, that was derived from an ISO draft a long time ago in 2010 as a simplified version of it with DC only, but that's also very well established, meaning there are a lot of vehicles out there which only do the DIN protocol. So you have to actually support both of these. They are very similar, but not compatible. And coming up, the next generation protocol, which was released by the ISO in 2018. That's the -20. The long-awaited feature in there is bidirectional, so the actual vehicle to grid, putting energy back to the grid, but also stuff like pantograph charging and positioning of the vehicle, wireless charging and positioning of the vehicle, and a lot of other enhancements for value-added services, and so on and so forth. More signing of messages, and a lot of that stuff, long awaited, and especially for the bidirectional stuff, you cannot really use the previous two protocols for that. You have to misuse them. There's no standardization on that. And the grid is really waiting for that now. We're all aware of that. So getting further into why we're doing this, the messages on the line are not transferred as XML documents, but instead as EXI. That is efficient XML interchange. That's a binary stream. If you skip onto the next page, I'll say a little bit about that.
That's one thing to add. So I think there's even more derivations of different, let's say, implementations upcoming. I think some of the US brands now trying to do bidirectional with DC, and I think then also if you look on the cars, everyone has sometimes a slightly different schema definition, and things are not working because of that. So it's really crucial to be flexible on schemas.
That's correct. There's a working group in the ISO right now who are trying to rework the DIN, because they say we don't want TLS, we don't want all the fancy stuff, we just want the DIN with non-TLS communication and bidirectional features. So that's another schema that's coming up, and someone needs to do code for that as well. That we will most likely, well, we will very likely cover that as well. So just to sort of hint at the difficulty, this is not actually a message. This is part of a message. There's also a V2G message type around this, and the header, and this is the body. This is the current demand request. It's one message type. You can see there's a sequence of elements contained, which again are complex elements, complex content. I won't go into the details, but this is a very simple message, just a general sequence of components which have to be transmitted as values. You can see at the end of the line, sometimes a min occurs equals 0, which means it's optional. Other messages are much more complex in terms of a hierarchy of values which have to be transmitted. And if we transform this into a message representation, so this is a schema that defines how the message is to be formed. If you go one slide further, there's an overlay of what such a message looks like, including the header and the body. Don't look at the details, but there are some enumerated values in there. There's some integers in there in a certain order, and they all have a certain meaning. And what EXI will do, you'll see at the end, it will put away all of this overhead of the the XML types, and just leave you basically with the content and a decision tree on what component is coming next, and that in a binary form. Let's see if I managed to explain that on the next slide. So all this formatting, including the name of each element and so on. So all the text stuff is gone. You need to have a knowledge of the schema, which says which element comes when and what are the next elements, or can be the next elements, because some are optional. So you need to know basically what is going on. That's sort of, I think it's defined as a grammar. So you have a decision tree, what comes next. And based on this sort of decision tree, the encoding only uses a certain number of bits and an event code to say what's coming next. So if you have at a certain place, you could either have element A or element B coming next. You have two possible elements. You basically need only one bit to indicate which of them is coming next. And then right next to that, no text, no nothing, comes that, for example, string or integer, or sometimes if an integer has a smaller range, it's only a couple of bits. In most cases, this actually implies using the minimum number of bits ever required. And it's also not byte aligned, which makes it basically non-human readable. You can recognize strings if they happen to be byte aligned, but if they're not byte aligned, you need to shift the bit stream in order to recognize them. So if you skip to the next page, you will see the graph is still the XML message there, and this is the hexadecimal binary representation of that message. It is just basically a couple of bytes. This is something like 25 bytes or something like that. That is what it will boil down to at the end. And this is what the hexacodec, so our encoder decoder needs to do. It needs to have this knowledge of the schema and be able to it doesn't parse the schema. You don't give it the schema files. The code we generate already knows the schema. So the code generator takes the schema and creates code for a given schema, or as we said, for several protocols, which is a handful of schemas. And it will then do exactly these bit encodings or decodings, say, here come 2 bits for that and 3 bits for that, and go through this order and be able to either assemble this bit stream or disassemble this bit stream and abstract the data, not as XML, because nobody in the real world has these values in their machines as XML. They are variables or something. So we represent them in the C or the Python or C++ case as something as structs or classes on the API. So you feed the codec with a struct representing the values which belong to a message. So right, verbose struct, which has where the members have names, obviously, and you put the correct values in, and the codec will put them into this compact bit stream, or the other way around, it will disassemble them into exactly that. That is exactly what we are building. So now, next slide, we're still on the motivation. Why are we building this codec generator? There are already open source codecs available. Marco mentioned the Rise V2G and Joseph stuff, which uses Xefficient underneath. That is done by Switch EV currently, or possibly also community driven. I'm not sure. But that's Java based, which is just very slow already on a PC. It's already very slow. You can't use it on embedded devices. Joseph is currently developing, or perhaps already has, a Rust-based alternative, exchanging the Xefficient part, which is the Java stuff, with their Rust implementation. But that will remain closed, and they will license it and sell it. The other alternative, which is sort of state-of-the-art right now, is the OpenV2G codec, which is developed by Siemens, just as Xefficient is, by the way, by the same person, I think, as well. They also generated this code with a closed source code generator. It's well established. Many products use this. We know this from the competition, from talking with people. Those who don't do what we're doing right now, i.e. write their own codec, they use the OpenV2G mainly. It has been updated from covering originally the DIN and early versions of the ISO to the current versions of DIN and ISO 1511-2. They also implemented a preliminary version of the next ISO, which we used to call version 2 of ISO-2, but they don't support the -20. They do if you hand them money, but they've made that into closed source and license, and it's very expensive. Even for us as a moderately large company selling quite a lot of components, it's expensive because it's on a per unit basis as well as a base price below that. I have an idea why they're selling it now, because they realized with the -20 the schemas have gotten far more complicated dependencies, more complicated definitions, more types being used, and they probably realized they need to do a whole rework of their code generator, and so they want to see money for it this time. We don't see a great selling point for it, so that's why it's going open source, but we're basically going to do the same thing. Another problem with OpenV2G, of course, because it's closed, as Marco mentioned, there are going to be probably more schemas. I mentioned a coming extension of the DIN 7121, and we've had customers, for example, which wanted proprietary extensions. They said, for an internal solution, can you not add this and that parameter? We said, no, actually, we can't. We don't have the codec for that. We can't do that properly. You have to misuse something in the standard protocol. So that can't be done because the generator is not publicly available. That is our motivation for writing our own codec generator, for being able to do all this stuff mentioned down here. Okay, next slide. So our project, current code name, or well, not code name, the project name, V2G XE Codec Gen. It's a code generator written in Python. We use a Python module named XML schema, which is an XML parser and validator, which means it can also validate XML files against the schema and so on. We only use the schema part, and it already has an option code gen, which is very practical, obviously. This code gen already uses Jinja 2, which is, I guess, well known in the Python world for code generation. So we are building on top of that. We use code templates. Jinja has a certain template coding style, which you can use to generate code on top of that. And so we have tons of code templates for types, for skeletons, for the init functions. Now we're building the skeleton for decode encode functions for all the types, and some are still missing, and so on. And a lot of logic around that, because they're always, well, I don't know, such a schema is quite complicated, and you need to cover everything in exactly the right way. XML schema doesn't do everything out of the box for you. So, for example, if there are restrictions on an element, you will have to let XML schema get them for you, and you have to do your own, or we have to do our own magic to apply these restrictions to the XE, because XE is doing something special about that. XML schema doesn't know about what XE does with special cases or restrictions. That is the part that we're basically coding around this. So that's what we're doing right now. On the next page, there's just one arbitrary template I took out of our 3,000 lines of code templates. So you can see the indentation levels, and it's a generic function for, I think this is probably a decoder. So you'll see it somewhere as a block, which is called grammar content, right in the middle where other code comes in. And this is sort of the basic skeleton for a decoder function, which then recursively builds up with additional elements later. That is what some of the templates look like. Some need to be expanded for new types and so on, which will be included again. And that all builds on top of each other. At the end of the day, you'll get a whole bunch of header files and C files, which can then be made into a library. That's what we're doing right now, and getting forward quite well. On the next page, we have the current state. So we are targeting C code. The reason for that is it's obviously a common denominator with C++, which much of EVerest is using. We're not generating C++ because C is still also required for embedded products at chargebyte, which are very short on memory. And actually, I think the compiler of the one product doesn't actually support C++. So that's why it still needs to be C. No other special reason for that, but it's pretty basic. So it shouldn't matter for anyone. It can probably also be made to target, for example, Python code. No doubt it can. If someone with a bit of knowledge does a new branch for that, the generators will generate a little bit C specific, so it will have to be modified a little bit, but it can be done for any other structural language, I guess. I took our code base today and just did a quick lines of code. So we have some 2,500 plus lines of Python code. That's the generator right now. The templates are some almost 4,000 lines and still growing. Some of those are is basic code just copied into a template. Might mention that later. We are configurable in many ways. First of all, which schemas to use, so you can point at the correct schemas if you want to have them, or you have a different set of schemas, which we, by the way, aren't going to be part of the repository because to our interpretation, the distribution license wouldn't allow us to put it in the same repository. Other projects, especially SwitchEV, they check them into their repositories. They can feel free to do so, but the license, I wouldn't put my name on that for releasing that. We can point everyone to where they can find them if they want to use the code generator later, but we're not distributing them ourselves.
By the way, this is also the recommendation from the Linux Foundation lawyers that based to our common interpretation, you're fine to distribute the, let's say, crunched version of the schema files, like the generated code, but the schema files itself are often part of the standard and redistribution is not allowed. Some standards are already changing and then have different license on the appendix with the schema files, which is allowing this. And together with the Linux Foundation, we want to make more of the standard committees aware of this problem and lobbying for, let's say, changing the license for the schema appendix.
Yep.
So we are kind of on it.
Yeah, for the -20, for example, there's actually the ISO organization has an actual download location for that, which is public, but it doesn't say that you can redistribute them. You can use the schema files, but you can't redistribute them. So I wouldn't publish them unless they put a different disclaimer on those. And perhaps you're working on that. Other features other configurations we have is the feature selection. Especially regarding with schemas, we can you might want to omit stuff. For example, on a DC charger, you won't want to do AC. You might not want to do pantograph or wireless charging. So you can actually omit that code, which is also fine for embedded if you want to really save on space. And there's much more configuration to be done there. We have an example configuration, or we have custom configurations. So, yeah, feel free to go on. We can already create the data types for all known schemas. All known schemas are these DIN and the two ISOs we're talking about. We can actually create decoders for DIN and ISO 1511-2. Not successfully yet, but not working all the way through, but I'll talk about that right now. The C code is warning free, of course, where we always track that along the way. We don't want to do all the cleanup at the end. So, but the intermediate state, as soon as this goes to the community, everybody's free to look at it and of course say that style is really bad, or there might be some difficulties with that. The C code, when compiled, can already decode quite a few ISO-2 messages. Those which it cannot decode, there are still type decoders for the elementary EXE types which are missing, which still have to be implemented and integrated. We're working on that right now. We is myself and Christoph, mainly Christoph is doing the generator code. So some messages fail to decode, but yeah, ongoing. And we have some misinterpretations. Go back one, please. Of schema. So right now, the DIN, which is, as I said, a very simplified version of the ISO, isn't working because they managed to define something in another schema file, and it just doesn't pick up correctly. The DIN should work out of the box if the ISO-2 works. And we're testing this with well-known XML files and exe streams. As I said, we have a lot of experience with this communication. You can extract an exe stream from a communication trace, from a PCAP trace if you want. We have already test cases for our old charging stack, which uses XML files and creates exe streams. And we are decoding these and already checking whether the same content comes back. We have exe streams for almost every message, but not for every corner case yet, so we have to create them. And we need, of course, other tools to create these exe streams, these reference exe streams. We can't test against ourselves yet. I didn't write it here, but the next step will be the encoder. The encoder we will be testing against our own decoder then, if the decoder is known good. Okay, next slide. Okay, now, of course, everybody's asking for the -20, and the other codecs are already available for OpenV2G. So why are we doing the -2 before the -20? Well, obviously, this is new stuff for us, a code generator and a codec, but we have references. So with the ISO-2 codec, we can see whether we're doing the right thing by just comparing, either using the reference inputs or comparing with, for example, OpenV2G encoding. That's very, very important because exe is really non-obvious. We went through some stages of the encoder, and at the end of the day, we were looking at single bits and wondering why it has to be this way and not the other way. So those are low-level details of understanding what exe says in the standard on how it is to be encoded, and sort of a bit reverse engineering by comparing it against other implementations and saying now it works. So we needed this reverse engineering to understand how exe works in some places. And the final bullet that's very important for us, we want to integrate this codec into existing products and check whether it works. It still works after taking out OpenV2G. And I don't know if it's obvious, but the API for it's pretty obvious that the API is very similar to OpenV2G because it's just a structural representation of data pressed into a message and back and forth. So our API will be very similar. The data types are named according to the data types in the XML. So it's very, very similar. So porting your software from OpenV2G to our codec is pretty straightforward with a little search and replace, and we're using little different namespaces now because OpenV2G had some bad name choices in some places and so on. That's very important for us, and that is one of the next steps. As soon as we have, I guess, the -2 basically working, we should also in parallel start integrating, and that's also the one that you will see as the donated component, which we talked about before. So finally, on the last slide, what are our next steps? Not necessarily in this order. ISO-2, finalize this. It says DCEIM and ACEIM. We start off with DCEIM, means external identification meaning anything which is not plug and charge. The reason for that is, again, plug and charge messages are a little more complicated. There are some very rarely used XML components in there which are a bit tricky, like arbitrary length integers and so on and so forth, which occur only at exactly one place in exactly one message. So and we have one internal product which doesn't have plug and charge yet, so it doesn't need that state. So we will just complete the EIM part and fix the DIN 71-1 as well. So we have those two. And then we can go into integration. Then next step is either the plug and charge messages to complete and finalize the -2, or we will skip on to the -20 messages. or as I said, we're working on the decoder right now, go on to the encoder. So we're a lot of different paths to follow here, and we have to do a little prioritization. But if you want to put this codec in place of the OpenV2G, you need both an encoder and the decoder. So probably we will stick with the lower features, complete the encoder and decoder, and then continue with the other features again, or do that in parallel. Fifth bullet, we also have some low-level bitstream codec stuff for the XE types. The encoders, we did not actually write them ourselves. We imported that into our code base. We might need to rewrite that for license reasons. It's pretty straightforward, but it's just a lot of work. On the top of the whole thing, we want to do a library API with more than just the structs and encoder functions. There's going to be a little bit of like boilerplate around the whole API. We will need a build environment to properly make this a static library or a proper software project as well. So we'll probably also have to generate something like the make files for creating a library and for perhaps creating helper tools and stuff like that. And then, not finally, but somewhere in between, we will go public and involve the community. So in the course of the next weeks, we'll put it on in one of the EVerest repositories on GitHub, and after an internal review, it'll go public, and we will continue working there. That's the way to go.
You're muted, Marco.
Sorry. Yeah, really, thanks a lot for the detailed presentation. I'm really looking forward to get that into the community. And yeah, just saying, make it public as soon as you can. So maybe doing this rewrite imported lower level bitstream codec first, because on everything else afterwards, we can basically involve the community as soon as we have, let's say, any license issues resolved. Would love to help there. Then quickly, what's next? We had before this timeline on what we're doing that got also deprecated because so much things happening in parallel. We'll just let this here for a second. We have to clean up our timeline, but in principle, a lot of things are done now. Basically, going forward, the next big things for us is OCPP 1.6 plug and charge and finalizing the smart meter, the smart energy management things, -20 for sure. As you heard, we're working on that. Advanced energy management will happen next year. The IEEE 2030.5 is on our radar. OpenADR, EEBOS, and yeah, basically priority also depends on the community and on commercial projects in the background. So whenever anyone is missing something, we're happy to adjust this. And so, 2 announcements at the end. So we want to have a detailed breakdown how EVerest works internally and how you, let's say, within minutes, configure totally different charging use cases within EVerest, and how also helping you with a really good development environment, and yeah, giving you an introduction how to use EVerest for your projects. Will be in tomorrow, in 3 weeks from now, also at the same time. The subscription, if you subscribe to our email list, you will get the registration link via that on the next days. And except that, we'll see each other either in about 4 weeks from now here in the same next TSC, or you can also join us every Tuesday, except next week because it's public holiday in Germany, at 10 o'clock CET, and join our ongoing architectural discussions and reviewing bigger merge requests and whatever we want to discuss. And yeah, thanks for your attention. I will stop now the recording and directly jump into further discussion with you, which won't be on YouTube. But see you next time here.